This video is a continuation of part 1. Both videos deal with using ratios and proportions to solve unit rate word problems. Now before we go forward, let's take a minute and look at one of the problems that we did in part 1, just sort of to catch us up here. A car can go 200 miles on 10 gallons of gasoline. At that rate, how far could it go on 1 gallon of gas? Well, the first thing we're going to do is we're going to try and figure out what information is the problem giving us. And we see that it's telling us that this car can go 200 miles on 10 gallons of gas. Then we'll look at what the problem's asking us to do to solve this problem, and that's to figure out how far that car could go on 1 gallon of gas. So what we're going to do is we're going to take the known information, the 200 miles and the 10 gallons, and we're going to express it as a fraction. And we're going to view this as a special kind of fraction. We're going to view this as a ratio. And a ratio is simply expresses the relationship between two numbers, in this case the 200 miles and the 10 gallons. Then we're going to do the same thing with the information we have that we have to use to solve the problem. In this case, how far that car could go on 1 gallon of gas. And that we're also going to view as a ratio. Now two of these together, when you have two ratios separated by an equal sign, together they're referred to as a proportion. And a portion is true only if both ratios express the same relationship. So if we look at the ratio on the left-hand side, we see the 200 miles and the 10 gallons, and this ratio is telling us that the numerator is 20 times greater than the denominator. And again, for this proportion to be true, both ratios have to express that same relationship. So that means the right-hand ratio has to also reflect a relationship where the numerator is 20 times greater than the denominator. Now this is a pretty straightforward one, and it's not too difficult to figure out how to make the numerator 20 times greater than the denominator. So we can see that the answer to this problem is going to be 20 miles. So what this is telling us is that if a car that can go 200 miles on 10 gallons could also go 20 miles on 1 gallon. So let's look at another problem. We'll keep the car problem above us visible so that we can sort of use that as a model. So a store sells 6 apples for $2.82. At that rate, how much would 1 apple cost? Well, we'll follow the same process we did in the first problem. And we'll look at what the problem is telling us. What's the known information? In this case, it's the 6 apples for $2.82. Similarly to the first problem, we'll look at what are we trying to figure out here, and it's how much 1 apple would cost. So we'll set up the fraction or the ratio using the known information, just as we did in the prior problem, and we'll do the same thing now down here for what we're trying to do to solve this problem. Now this time, if we just look at the ratio on the left-hand side, it's not quite as easy to see the relationship as it was in the prior problem. It was pretty easy to see in the first problem that 200 was 20 times 10. This is a little bit more difficult. So what we're going to do is we're going to solve this problem in a slightly different way. We're going to do some calculations to try to figure out how much 1 apple would cost. So what we'll do is we're going to multiply the numerator on the left-hand side ratio by the denominator on the right-hand ratio. And we're going to multiply the numerator on the right-hand ratio by the denominator on the left-hand ratio. And this is called cross multiply. Hopefully for fairly obvious reasons. And when we do the multiplication, we end up with 6x equal to 2.82, or the $2.82. Now this is a pretty straightforward algebra problem here. What we'll do is as we solve for x, we'll divide both sides by 6, and what that'll give us is x is 47 cents. And since we had let x represent how much 1 apple would cost, this is telling us that if 6 apples sell for $2.82, that one of them would sell for just 47 cents. Let's do another problem. In this case, a bakery can make 148 bagels in 4 hours. At that rate, how many would they make in 1 hour? So same process here. We look at what we know, it's 148 bagels in 4 hours. We look at what we have to do to solve the problem. We have to figure out how many they would make in 1 hour. We create our first ratio using the known information. We create the other side ratio using what we have to do to solve the problem. This looks very similar to the previous apples problem. We'll do the cross multiply, and that'll give us 4x equals 148. We'll divide both sides by 4, and what that'll give us is x equals 37. So this is telling us that if they can make 148 bagels in 4 hours, at that rate, they'll be able to make 37 bagels in 1 hour. One more. This time, Pat traveled 195 miles on his motorcycle in 3 hours. At that pace, how far would he travel in 7 hours? Now, this is similar, but not exactly the same as the previous two problems. Remember, both of the previous ones asked to find out how much one apple would cost and how far he could go on 1 gallon of gas. In this case, we're sort of looking forward to how far he could travel in not 1 hour, but in 7 hours. Despite that, we solved the problem exactly the same way. The information we know is the fact that he can go 195 miles in 3 hours. What we have to do to solve this problem is figure out how far he would travel in 7 hours. You know the drill. We set up the fraction or the ratio for the known information. We set up the ratio for what we need to do to solve this problem. And again, it doesn't matter whether you put miles on the top or hours on the top, but what you do have to do is whatever you put on the top has to be the same on both. So the fact that we have miles in the numerator on the left means we have to use miles in the numerator on the right hand side. So here we go, we do our cross multiply thing, and we get 3x equals 1,365, which is 195 times 7. We'll divide both sides by 3, and we end up with x equals 455 miles. So at a speed of 195 miles in 3 hours, he would travel 455 miles in 7 hours. All right, one last one. He worked 12 hours this week and made $132. If she works 15 hours next week at the same pay rate, how much will she make? So you ought to be able to figure this one out by yourself. We'll get you started here. This is the known information. The next few steps should be sort of obvious to you by now. Why don't you pause the video and see if you can run through the rest of this problem and figure out how much she would make at the same about rate of pay. Go ahead, I'll wait. All right, so we know what the known information is, the 12 hours and $132. So what we need to figure out is how much she'll make if she works 15 hours. So here come the two ratios, the first one reflecting the information that we know, the second one reflecting what we have to do to solve this problem. And again, notice that hours is on the top on both sides. Cross multiply, 12x equals 1980, which is 15 times 132. Divide both sides by 12, and we end up with x equals $165. So if she makes 12 hours, she works 12 hours and makes $132 at that same pay rate. If she worked 15 hours, she would make $165. Now, if you're interested in getting some more practice at doing these kind of word problems, I would strongly recommend you go to the website that you see on the screen here. This www.math-aids.com is a really good website. They offer a wide range of practice problems on a number of topics. And this particular URL that you're looking at here will generate word problems very similar to the ones that we've done in this video and the prior video. One of the things I really like about this website is that they not only generate the problems, but they also give you the answers so that you know whether you're doing the problems correctly or not. So again, if you're looking to get some more practice at this, I would strongly recommend you go to this website.